I think it's interesting that we don't talk about a heating curve for water until second semester of general chemistry, when it's one of the first things that we cover in intro. But so that should tell you this is not hard. This is not hard. Okay, so we've got this heating curve, and we call it a curve, but it's really a series of lines at this point. Now, so this segment here, so we got temperatures at 0 and at 100. So these are obviously important. So we're dealing with water, but every substance is going to have a heating curve. The temperatures are just going to look a little bit different. So on segment A, that occurs where you are going to be heating solid ice. So heating the solid ice. So we're applying to it. And so the specific heat for ice, so specific heat of ice is 2.09 joules per gram degrees Celsius. Now, it's important here when we're talking about in these values, some are going to be in grams and some are going to be in moles. So you have to be careful when you're doing some of these calculations. Okay, and again, these specific heats and vaporization value, the values will be given to you. It's your job to know how to apply them. Now, notice right here, we're applying heat over time, but it's not getting hotter. So this process where heat is being applied, but it's not getting hotter, this is actually melting. So the temperature in this case does not change. So in that case, you have both liquid and the solid. They're kind of coexisting through there. And so here the heat would be number of moles times heat of fusion. And heat of fusion for water is 6.02 kilojoules per mole. N's number of moles. Up here, you're heating a solid, so this is joules per gram, so Q is going to equal MCAT, MC delta T. Now we get over here to this segment. So here, this was heat ice. Here, this is melt ice. What do we have when we melt ice? We get liquid water. So now, if we have liquid water and we want the temperature to go up, what are we doing? We're heating it. So here, this is heat water. So here, heat liquid water. And so here, this is also going to be Q equals MC delta T. Specific heat of water is, maybe you remember, 4.18 joules per gram degree Celsius. After we've heated water up to 100 degrees Celsius, we've got another horizontal line. So here we have liquid and we're going to gas. So we call that boiling. So here we're boiling water. If you want to be all scientist and say we are vaporizing water, you would be 100% correct. But most people don't talk like that, so I try not to say it that way. All right, make sure you can still see all that. So we're boiling water. So when we boil water, that means we got liquid and gas. So Q equals number of moles times the heat of vaporization. And the heat of vaporization for water is positive, should be what, 40.7 kilojoules per mole. And then, so here, this is boil water. And so now, what do we call boiled water? What do we call gaseous water besides water vapor when it's this hot? I hope you said, Dr. B, that's steam. Yes, it is steam. And the temperature is going up, so what are we doing to it? We're heating it. So here we are going to heat steam. And so to do that, this is another MC delta T. The heat, specific heat of steam is 2.01 joules per gram degree Celsius.